HTML5.
Hi there, welcome back. You've got Mike here. Today I'm going to explain what I've been working on with the Kinect, and I'm going to demonstrate my home automation system. This video will be presented in two parts, the first explaining some new software for the Kinect related to home automation, and the second explaining the home automation system. Let's start by taking a look at the controller that runs the Kinect server and web interface. We connect the controller to the network and apply power. The controller takes about 30 seconds to boot and is ready shortly after its status light begins flashing. With the controller up and running, we type its address into a web browser to connect to the web interface. Keep in mind this is all work in progress. Since the camera hasn't been plugged in yet, we get an offline message. So we plug the Kinect into the controller's USB port, and it comes online shortly thereafter. Now we see the depth information from the camera, as well as a message indicating the Kinect is online at 30 frames per second. The second tab provides an overhead view of the room generated from the depth image. You can see me at my desk as well as various features and walls in the room. You also have a side view and a front view, all calculated from the same depth image. Automation trigger zones are created by clicking and dragging on one of the views. You enter a name for the zone, subject to certain restrictions, and the zone is created. The new zone shows up in the list of zones to the left of the screen, and its extent is shown on the views to the right. We can see detailed information about a zone by clicking its name in the list. Here we see the zone's approximate dimensions in the room and screen coordinates. The zone is also visible on the other views for easy adjustment. Now I'll make some adjustments to the new zone to get it to cover just the part of the room that I want. You can see the zone's population update as I move into and out of the zone. Zone details can be hidden by clicking the zone's name again, and by clicking the X to the right of its name, the zone can be deleted. For the rest of this demo, I'll connect to a copy of the web interface running on my computer since the code isn't fully optimized yet. Keep in mind that the Kinect is still attached to the controller. Hovering over a zone highlights that zone with stripes, making it easier to set up zones when you have a lot of zones. You can hide and show the zones to get a clearer view of the background if necessary. Opening a zone's details raises that zone in the views. Multiple zones can be raised at the same time. Now you can work with previously obscured zones. As I walk around the room, each zone is highlighted to show that it's occupied. The zone with the highest occupation has its name shown in green. Now I'm going to talk about the protocol that you can use to interface with my software. The first method is reading JSON data from the web interface. The zones are included as objects in JavaScript object notation, as well as the sensor status and frame rate. The second method is through a simple command-based protocol over a TCP/IP connection. The server provides commands for manipulating zones, getting server information, and getting raw depth images. For example, to see the frame rate, you use the FPS command. To get a list of zones, you use the zones command. You can subscribe to zone changes as they happen using the sub and unsub commands. You can retrieve raw depth images with the getDepth command. And you can manipulate zones using the setZone command. This is the protocol used by the web server to communicate with the Kinect backend. It's also used by the temporary code written in Bash to control my home automation system. Now let's take a look at the home automation software, codenamed Palace. It uses functional building blocks put together in a graphical canvas to control the automation system. We'll start by creating a pulse generator which switches its output on and off periodically. We've told the object to switch on and off every 10 logic cycles and given it a name. Now we'll simulate it and you can see it switching on and off. The simulation runs at 20 updates per second, but the devices themselves can be configured to run faster. Now we create a counter to count the number of pulses. After naming the counter, we run the simulation and watch it counting the pulses from the pulse generator. You'll notice the outputs of the counter are blue, indicating an integer value. We'll add a comparison next, which will reset the counter when it reaches a value of 10. We connect the output of the comparison object to the reset input of the counter and run the simulation to make sure it resets when it reaches 10. Of course, there's a better way to do this without using the comparison. The edge counter itself supports range limits. Using the wide selection of building blocks available in the system, one can create a sophisticated automation system. With the basics out of the way, we'll consider a more practical example. We'll use a Griffin PowerMate to control some lights. Both the PowerMate and the lights are connected to the system by USB. First, we create an object that interfaces with the PowerMate. Since the PowerMate has a momentary button and relative rotary encoder for its dial, we need a latch and accumulator to keep track of those values. We combine the latch and accumulator with a simple multiplier. Then we add a moving average so the lights fade smoothly on and off. Finally, an object is created for the USB to DMX adapter to control the lights. DMX was chosen because of its fast update rate. Now we'll run the simulation and watch the knob control the lights. When the knob is pressed, the lights turn off. Press it again and the lights come on. If I rotate the knob counterclockwise, the lights dim. Rotating it clockwise increases brightness. Pressing it again turns the lights off again. These concepts can be applied to create a fully featured automation system, such as this one that controls the lights and projector in my apartment. The logic design is then uploaded to a controller for 24/7 operation without a computer. Thanks for watching. As always, if you have any questions or comments, you can get in touch with me on my blog at nitrogen.posterous.com.